Hey everybody. So we are getting into 4.3 today, proving lines are parallel. All right. This lesson you're going to see is very similar to the previous couple lessons when we were learning about parallel lines and transversals. All right. But today what we're using is the converse of the corresponding angle theorem and the same side angle theorem that we learned in the past lesson. So let me just kind of make some sense out of this, or real quick, actually, go ahead and get the title on your paper. Go ahead and copy this slide here, and then I'll get into it. Okay, so if you guys remember in the last couple of lessons, here's what we learned. We learned that if these lines were parallel, crossed by a transversal, then we could say that corresponding angles were congruent. All right, so that was the idea. Since the lines were parallel, we got congruent angles. Okay, today we're going to be doing the converse of that, or the opposite. And so here's going to be the logic today. They're going to ask us, are the lines parallel? Okay, and for us to answer yes to the lines being parallel, these four types of angles need to follow their rules. Okay, so for example, for these lines here to be considered parallel, here corresponding angles must be congruent. Okay, so if we can prove that this angle is congruent to this angle, we can say then yes, the lines are parallel. Okay, and then you guys remember alternate interior angles is the same idea. Those also need to be congruent to one another for us to say that we have parallel lines. So if we can say that this angle is congruent to this angle, that means yes, the lines are parallel. Okay, alternate exteriors, here's an example of those. If we can say that those angles are congruent, then we can say yes, the lines are parallel. Okay, and just remember guys, for the same side interior, it's not that these angles are congruent, it's that they are supplementary, that this one, when added to this one, would add it to 180 degrees. And if that's the case, then we can say yes, the lines are parallel. Okay, just a little reminder, little arrows on the lines is how we represent them as being parallel. Okay, so it's very much the same idea. It's just instead of saying, oh, the lines are parallel, that means we have congruent angles. Today we're saying, oh, we have congruent angles. That means the lines are parallel. Okay, the converse, or you can think of it as kind of the reverse of what we were using yesterday, but it uses the same rules. So let's get into it. All right, so go ahead, take a minute, copy this whole slide here, and we'll make some sense out of it. All right, so this example is asking, are the lines parallel? And then it wants us to explain our reasoning. So this is going to be a yes or no answer, and then we'll give a little explanation why we're saying yes or no. All right, but here's the given thing. Okay, this is the information they're telling us. Okay, they're telling us that angle 3 plus angle 6 equals 180 degrees. All right, so let's make some sense of that. Here's angle 3, and here's angle 6. Okay. One thing I want to point out, the reason why I'm putting two arcs here and one arc here is because I'm not implying that these are congruent. I'm noticing that these are same side interior angles. Okay. And just remember, those are the ones that aren't congruent. I usually make these ones red. So I guess I'll follow that same. Okay. But what this implies is that this angle here is not congruent to this angle. That's why I put two arcs and then one arc, just so you know. All right. So back to what it's saying. It's telling me that these two angles, when added together, equal 180 degrees. Well, if you guys remember, that is the rule with same side interior angles for us to have parallel lines. Okay, so since these same side interiors add to 180, since they're supplementary, we can say yes, these lines are parallel. Okay, so there it is. Our answer is yes. Okay, and our reasoning here is basically what I just said. I'm going to say because same side interior, we'll just shorten that, interior angles are congruent. Okay, so using some shorthand here, but you guys know what that means. Okay, I just want to kind of throw out an example. What if they had told us that angle 3 plus angle 6 equaled 181 degrees? Okay, these two angles added up to 181. Would we be able to say that these two lines were parallel to one another? Okay, the answer would be no. okay, because that is not the rule that same side interior angles follow for us to have parallel lines. Okay, so that's the idea with what we're doing today. Okay, all right, let's keep going. Okay, so same directions, you don't need those. Go ahead and copy this here. I would copy another set of lines and transversals just so we can mark them up. All right, so this is telling me that angle 4 is 70 degrees, angle 8 is 71 degrees. So let's make some sense out of it. I'm going to mark up my angles. So angle 4, this one right here, they're saying is 70. And angle 8, this one right here, is 71 degrees. All right, so I guess, first thing to realize on all of these problems is what type of angles are we looking at here? All right, and this is still something that you might, struggle with. But here are my two lines. Okay, here's my transversal. So I'm just kind of breaking this down because I want to make sure we're on the same page. But we have angles that are on the same side of the transversal, same side of these two lines below them. And I'm saying two lines, not parallel lines, because we don't know if they are yet. Okay, so these are considered corresponding angles. All right, here's what we know about corresponding angles. They need to be congruent for our lines to be parallel. Okay, so that's the question. Are my corresponding angles congruent? No. Okay, looks like 170, looks like 171. So can we say that these two lines are parallel? No. All right, and again, I'm going to write out my reasoning. I'm going to say because the corresponding angles are not congruent. So because we'll shorten corresponding to just COR. So corresponding angles are not, we'll make that big, congruent. Okay, that's why we're saying no, these lines are not parallel. Okay, and you guys could imagine, say instead of saying that angle 4 was 70 degrees, say they had told us that it was 71 degrees. Okay, my corresponding angles would be congruent, and I would be able to answer that yes, the lines are parallel. Okay, because corresponding angles need to be congruent for the lines to be parallel. Okay, but they weren't congruent, so the lines were not parallel. All right, so I'm gonna have you guys, I think, try one out. Yeah, okay, so same directions here. Go ahead and get those. Copy this, get the angles again, mark the angles because I think that's really important, and then we'll make some sense out of it. Try it out. All right, so this is telling me that angles 3 and 5 are congruent to one another. Okay, they're not giving me the actual measure of the angle, but they're telling me they're congruent. All right, so let's mark it up. Angle 3 is this one, and angle 5 is this one. Okay, first thing I hope you guys noticed is that these angles here are alternate interior angles. And again, I want to just break that down because it's so important to know that they're alternate interiors. So here's my transversal. Notice they're on alternate sides of the transversal. One's on this side, one's on that side. Okay, and they're on the interior of these two lines that are potentially parallel. Okay, they're on the interior of them. So they're alternate interiors. Here we know that alternate interior angles, the rule is that they need to be congruent to one another, and they told us that they are. So are these two lines parallel? Yes. Okay, and the reasoning really is the main thing. So let's point out that these lines are parallel because these alternate interior angles are congruent. Okay, we'll shorten this a little. So alternate interior angles, that's how I like to write it. Okay, because alternate interior angles are congruent. Okay, so yeah, a bit more, practice on what those types of angles are. It's just thinking of it in a slightly different way. But if you're still struggling on identifying which angles are which, like if I threw some, alternate exterior angles at you and you didn't know they were alternate exteriors, for now that's okay. But refer back to these notes or maybe the previous notes if you're still having trouble with, figuring out which are which. Okay, but if you are, like I said, don't stress too much. You were still learning this stuff. We're still getting it. Okay, so moving along here, let's try some problems that are giving us some weirder values. So go ahead, take a minute, copy this stuff, the whole thing, and we'll try it together. All right, so that's saying suppose that angle 4 is x plus 20, angle 8 is 2x plus 5, and x equals 15. Okay, so this is stuff they're telling us, suppose this exists, all right? Are the lines parallel? That's what we're trying to figure out. All right, so first thing, whenever they give you information like this, get it onto your angles or your picture, and it starts to make a little bit more sense. So let's write this stuff out for us. They're saying that angle 4 is x plus 20. So here's angle 4. Just going to highlight it, and it's x plus 20. Here's angle 8, 2x plus 5. Okay, so here's what I know. For these lines to be parallel, just to highlight it, they're asking, are these lines here parallel? Okay, first thing I notice is that these angles here and here are corresponding angles. Maybe the first thing to always ask yourself, what angles are we dealing with? They're corresponding angles, right? Same side of the transversal, same side of the parallel lines, both below them, or the potential parallel lines. So here's what we know. For these lines to be parallel, these two angles must be congruent. They must be equal to one another. All right, so I'm going to start writing out my equation. I know that x plus 20 needs to equal 2x plus 5 for these to be parallel lines. Okay, here's where this problem's a little different. They're giving us the value of x. We're not solving here. They're asking us, is x equals 15 the answer to this equation? Okay, and to figure that out, we're just going to plug it in and see if we actually get something that works, something that makes sense. Okay, if it makes sense, that means that these are parallel lines. If x does not equal 15, if that doesn't work, then we'll say no, the lines are not parallel. Okay, so let's go ahead and plug it in. So I'm going to plug in 15 for x in both spots. So I'm getting 15 plus 20 on the left. On the right, I'm getting 2 times 15 plus 5. All right, and really something you might want to throw in is this equal? That's really the question here. Is this side equal to this side? Okay, well, let's see. 15 plus 20 gives me a 35 on the left. All right, and over on the right, 2 times 15 is 30. 30 plus 5 gives me 35. Okay, so it looks like that when we plug in 15 for x, we get something that makes sense. 35 does equal 35. Sometimes I like to put a little check mark next to it. Okay, but that does work. Okay, so that means this whole situation, this made up thing they gave us, it did work, and that means that yes, in this situation, the lines would be parallel. Okay, so ultimately that is our answer, yes. Okay, so I'm really breaking it down. I'm talking a lot during these problems to hopefully help you understand what they're really asking for here. Okay, but really all we did is we put these values on, we made our equation, we plugged in a number, checking to see if it works. Okay, this is algebra stuff, we've definitely done before. I'm just making sure you understand the context. Okay, let's try another one here. So this one is asking us to find the value of x that makes the lines parallel. So take a second, copy this, we'll try it together. Okay, so find the value of x that makes m parallel to n. Here's something that we might not have seen yet. These two vertical lines, this is the shorthand for the word parallel. If you ever see this, they're telling you parallel. Okay, so we're trying to figure out what is the value of x that makes these lines parallel. All right, so on this problem, they're not giving us a value to plug in. They're just asking us to make an equation and solve it. What does x equal is basically the answer, or the question, sorry. So here's the first thing to realize. This angle here and this angle here. Okay, first of all, real quick, think about what of the 4 types of angles do we have right here? Okay, I'm hoping you thought, oh, corresponding angles. All right, and again, here's the reason why. They're on the same side of the transversal, both to the right, and on the same side of these potentially parallel lines, or I guess they are parallel. They're both above them. Okay, so that is what makes them corresponding angles. And we know that the rule of corresponding angles is they are congruent. Okay, so let's go ahead and do it. I know that means 3x plus 5 equals 65. Okay, and now I'm going to solve and I'm going to find the value of x that makes these parallel. So let's go ahead and do it. Looks like I'm going to subtract 5 from both sides. I have a 3x equals 60. And 3 is being multiplied, so we'll divide both sides. And it looks like x is going to go, 3 is going to go into 60 20 times, right? Okay, so there it is. When x equals 20, these lines are parallel. Okay, that's the value of x that makes these lines parallel. And again, just to kind of give you a greater idea of what this problem's asking, if we plug in, say x equals 21 into these angles, we would not have parallel lines. Okay, we would have to plug in 20 for x for these lines to be parallel. That's really what this question is trying to make us understand. Okay, so I'm gonna have you guys go ahead and try out one of these on your own. Okay, it's the same directions. You probably don't need to copy those again. Okay, but go ahead and copy this problem and make your equation here. Okay, here's one thing I just want to point out. These two angles, I just want to point out, we have this angle here and we have this angle here. Okay, first thing to realize is what type of angles do we have here? Which of the 4 types of angles? Here, I'll flip back real quick so you can see it. Okay, which of these 4 types of angles do we have on this problem? Okay, give it a guess. All right, so here's what I'm hoping you notice on this problem. Okay, these angles are on the same side of the transversal. Okay, but they're on the interior of these parallel lines. Okay, these are same side interiors. All right, since they're same side interiors, here's the next question. Are we going to solve for x, are we going to set these equal to one another? Are we going to say 2x equals x? What do you think? Okay, hopefully you're thinking, no, Mr. Stone, same side interiors are not equal. They're not congruent. They are supplementary. They add to 180. Okay, so now that you have that, go ahead and write out that equation, solve for x, see what you get. All right, so big thing, realizing same side interiors are supplementary. So I'm going to go ahead and write out my equation and say that 2x, that angle, plus this angle, x, equals 180. All right, just be very careful. It might have been tempting to set these equal and say, oh, 2x equals x. Okay, no, because same side interiors are not congruent. They are supplementary. All right, so now that we have that pretty simple equation here, right? 2x and an x gives me a 3x. And dividing 3 from both sides, it looks like x is going to equal 60. Okay, and there's our answer. When x equals 60, these two lines are parallel. Okay, if we plugged in any other number, like say 65, these lines would no longer be parallel. Okay, that's the idea. All right, so yeah, some more practice here on parallel lines and transversals and these 4 types of angles here. Hopefully you're starting to get comfortable with identifying them. That's still really the big thing I'm worried about, is you being able to identify, oh, these are corresponding, these are alternate interiors. Okay, if you're still having trouble with that, stick with it. We'll get it. Okay. All right, guys, I'll see you later. Bye.